rubric because I apparently didn't take enough copy. So, I want to start by talking about the rubric. Again, you've used these before, so you should have a pretty good idea. You've done 3 lab reports already. Before you start typing up this lab report, look back over those 3 lab reports. Mrs. Lockhart's really loud. Before you start typing these lab reports, this new lab report, make sure you go back over the previous 3 and just look at the comments, look at the scoring rubrics, and if you lost points for stuff, so you don't lose points for those same kinds of things, okay? So again, you have a cover page. Remember, that's a separate page on the front, okay, with the title, name, and date. Then you get into your body of your report. The things that are in bold should be like headers or little titles throughout your lab report, right? Purpose, theory, it's a lot of definitions. Remember, you're not going to like do ionic compound dash and then give you a definition, right? You're going to use all those definitions in a complete sentence and in a paragraph form on your lab report, okay? Experimental, the steps that you follow. Again, you don't have to copy it. I wouldn't copy it straight from the lab sheet. I would summarize it in a couple sentences or paragraphs. Results, it's a lot of results here, okay? Balanced equation data sheet, we'll talk about what that is. 25 balanced equations, including state of matter. I'm going to ask you to right now, for the balanced equation data sheet, to make a note on your rubric. That is to be handwritten. I do not want it typed. It is way too hard. You have to have superscripts and subscripts, and you can't do that effectively when you type. I want it handwritten. I would like you to maybe rewrite a final copy of it in pen, okay? And you all are savvy enough, tech savvy enough with this that you know how to take a picture of it and put it right into your lab report right there, right? Okay? So the 25 balanced equations and the net ionic equations, that's going to be handwritten, but then a picture put into your lab report probably, okay? The observation data sheet, that definitely can be typed, okay? And then the unknown data table, data sheet also is probably going to be typed, and we'll see what those are as we talk about the lab. Discussion and conclusions, again, there are some questions for you to answer. And then the other stuff, right? Spelling, every time I find a spelling mistake, you're going to lose a point. Grammar, each time I find a grammatical mistake, you'll lose a point. Absence of contractions, remember you shouldn't use don't or shouldn't. Again, my suggestion would be when you're typing your lab report is you just don't worry about that. And then when you're proofreading your lab report, you go back through and you're kind of carefully looking for, oh, there's a contraction, just fix it. Oh, there's a contraction, fix it. It's like too hard to try to remember to not do that when you're typing it up. So I would go back after you're done typing up your lab report and kind of reread through it looking for all of those things. Or have somebody else read it for you, like a parent or something, and hey, tell them, like if you find a don't or something, tell me because we've got to fix it. And then formatting, again, that's just that you have your sections titled, that's that you have your last name and page number up in the upper right-hand corner, all of those sorts of things. It's a lot of points, should be easy, a lot of points, okay? Does that make sense? Idea is this is sitting next to your Chromebook or your computer as you type up your lab report.
I'm so happy to have it in paper.
So that is that. So let's take a look then at the actual procedure that you're going to do tomorrow if it's not a snow day, Monday if it is. Okay. So you'll notice this one looks a lot different than the other ones you've done. This is one that I got from a former chemistry teacher over at Morley Stanwood High School. So reading the purpose, please. Madison?
This lab deals with aqueous chemical reactions which may produce insoluble products. This lab enhances the ability to write balanced chemical equations, write net ionic equations, and predict precipitate formation based on solubility rules.
You guys, by the time you do the 25 of these, writing and balancing the 25 equations, potentially writing 25 net ionic equations, and using those solubility rules that we talked about on Tuesday, you should be pretty comfortable and in good shape for your test. That's why I would really encourage you, if it is a snow day tomorrow, to spend the day doing that. Because you're going to either have some questions for me on Monday about stuff that you're unsure about, or feel like I've got this, I'm ready to go, okay? The introduction, please, Sean?
Precipitate formation can be predicted by using solubility rules and testing experimentally different combinations of solutions of known ions. The net ionic equation is a boundless chemical equation that represents the formation of the precipitate. Spectral ions are not shown.
Okay, so again, just kind of defining that precipitate. All right, the materials, Alyssa?
Materials used for the slab for the current data table.
Acetate.
Acetate sheet, a sheet of black paper used for contrast, and a set of
Aqueous.
aqueous chemicals. The set of chemicals involved in the slab. Do you want me to read them all?
You don't need to read them all.
Okay.
The part that's important is that line underneath. The lab also includes a set of unknowns from the above list of solutions. Your unknown that you'll have to identify is one of those 10. You just have to figure out which one of those 10 it is. It's not some combination of them, okay? It's exactly one of those. Now, let's take a look at your grid data table. That's this page. Okay, this page is your grid data table. Acetate sheet, that's a piece of overhead projector. So that's already made for you and ready to go. This is copied onto that overhead projector piece. So this is what it's gonna look like when you do your actual lab. You'll be doing your reactions in these tiny little squares. Okay? What many people choose to do for writing an observation is many people choose to use this to write observations on when we start to talk about observations. Okay? So that's that part. It says a sheet of black paper. You won't need black paper, you'll need a white paper. Our lab stations are black, and you're gonna want a piece of white paper to look at these with, okay? So you'll need a sheet of white paper. All right, the caution, Rainey.
Avoid physical contact with any chemical, and in particular with potassium hydroxide and silver nitrate. Both are hazardous materials.
All right, so I came in contact with both of them this morning, and I'm still alive. So goal is to avoid contact. It is not a flip out and freak out if you do. It's a go wash your hands with soap and water and get them off your hands. Silver nitrate, usually I must not have come in contact with much silver nitrate because silver nitrate will stain your fingers. It also will stain your clothes. So Monday might be a good day to not, or tomorrow, whichever day it is, might be a good day to not wear your very best brand new clothes to school. Like wear some older clothes that if by chance you get a little bit of silver nitrate on your clothes and you get a little stain there, it's not the end of the world, okay? All right, the 25 chemical reactions, Margot.
On a separate piece of paper, number 1 through 25, then write the balance of the set of 25 reactions. Using the solubility rules, predict the state of each product and denote it by using the subscripts for precipitate and AQ for the aqueous solutions. For each reaction will require 3 lines of paper. Line 1. For each reaction, write the balanced chemical equation and use the solubility rules to predict the state of each product. Line 2. For each reaction that produces a precipitate, write a balanced net ionic equation. If no precipitate is produced, then write none on the second line. Line 3. An empty line will be used as a spacer between reactions.
So this is, what this is describing right here is from your rubric, this is that balanced equation data sheet. Right, I called it on your, it was called your 25 balanced equations, including, it's called your balanced equation data sheet. That's what this is describing. So let's take a look at that. Let's look at that last page that has all the reactions. And let's kind of imagine I have a lined piece of paper up here. Because I would like you to do this on a lined piece of paper, okay? And then, like I said, I would honestly probably do my rough draft right on here, okay? And then I'd make a kind of final copy in pen on a nice lined sheet of paper. So let's look at this. So number one, and I would like you to kind of number the reactions somehow, okay? So number one is Na2CO3 plus CuNO3 2 yields. Now, a couple of things about this, right? It says that you're going to use the solubility rules to figure out the states of matter. Well, I'm going to help you out right now if you write some things down and you listen. The state of matter of all the reactants is aqueous. You don't need to look them up. They are all aqueous solutions. So the state of matter for every single thing that's already written on your paper is aqueous. You don't need to look them up. Save yourself some time. Does that make sense to everybody? Okay? Now, it's asking you, right? It says the first thing to do is to write a balanced chemical equation. So what kind of reaction is this? Double replacement. What happens in a double replacement reaction? We switch partners. Who's alike? Sodium and copper. Right? So they're going to swap partners. Now, what kind of compounds am I going to produce? Ionic or molecular? Ionic. So I'm going to have to do Margot's favorite things. All those steps, right? I'm going to write my symbols. I'm going to write my charges. I'm going to crisscross and make sure it's Lewis number right ratio for every single blank on that paper. You have to do those 4 steps. Okay? So my symbol for sodium is Na. What is its charge? How do I figure out its charge? Thank you. So its charge is +1 because it's in group 1A. All right, its partner is now going to be what? Nitrate. What's nitrate? Charge of? Anything to do to that one? No. Again, leave myself some room to put my state of matter and leave myself some room to put coefficients. All right? Copper. What is copper's charge?
You have to look at the helper sheet.
Okay, but my helper sheet's not going to help me because it has more than one possible charge.
Oh.
How do I figure out copper's charge here? Right, I look at this, right? This is -1. How many of them are there? 2. So remember that means I have a negative charge, total of -2. This is an ionic compound. It can't have a charge. So what does my total positive charge have to be? +2. So what's copper's charge here?
+2.
So what's copper's charge over here? +2. It's not going to change. Okay? And who's its partner going to be? Carbonate, which is charge of? Anything to do to that one? No, I mean I could crisscross down 2's, but then I would have to reduce. So this is now a skeleton equation. Let's balance it. What should we do to balance it? Coefficient of 2 where? In front of sodium nitrate. So coefficient of 2 in front of sodium nitrate. Does that balance it? Yes. Now, when you write your final one, right, you're not going to have these little arrows here. Right? And remember, when we rewrite our chemical formulas, we're not going to have our charges in them either. Okay? Now, we need to do states of matter, so find your helper sheet that has the solubility rules on it.
when we do them, like on our paper, over on this side, you don't want like the pluses and the minuses.
When you like right now on your rough draft, it's fine. But remember we talked about if I'm gonna recopy this, when I write compounds, they shouldn't have charges in them.
Okay, just on the
When we
right
do the
side.
net, anywhere,
Okay,
okay,
like even over on these ones. if you
even
do.
on those
Okay.
ones, right, yeah. So what this would look like at this point on my final copy that I'm gonna turn in is I wouldn't have any of these charges in here. When you're gonna take the time to rewrite it, they should disappear out of there, okay? Now, states of matter, what rule number are we gonna use for this one? 2, it says nitrates most are soluble. Is sodium listed as an exception? So what should I put as my state of matter? Okay. How about this one? What rule number? 5, right? Carbonates, and it says carbonates are most are insoluble. Is copper listed as an exception? So what should I put for its state of matter? Solid. So see how when you've done that 50 times, you're gonna be pretty comfortable with this? Now, one thing I'm gonna tell you, and again, I would make a note to yourself so you don't flip out about it. There are gonna be some of these reactions where both of your products will be aqueous. Because that's gonna mean that no reaction takes place, and some of these reactions, nothing's gonna happen when you do them in lab. So I don't want you to flip out, okay, about the fact that when you do this, sometimes you're gonna get both products as aqueous solution. That's okay. That's nice, because you won't have to do an anionic equation. Okay? So, now, right, we've done step number 1. For each reaction, we've written a balanced chemical equation and we use the solubility rules to predict the state of each product. So we've done that. Second line, for each reaction that produces a precipitate, which this one does, we're going to write a balanced net ionic equation. If no precipitate is produced, we write none. So if these had both been aqueous on the second line, we would write none and then skip a line. But this one produces a precipitate. So somebody know the trick? You can do complete ionic equations if you want, okay? Remember we're getting rid of the spectator ions, right? Okay? So I'm gonna tell you that the spectator ions are sodium ion and nitrate ion. So my net ionic equation for this one is, and it doesn't matter what order you write it in, CO3, -2 aqueous. Remember when I'm doing that ionic equation, I need my symbol, I need my charge, I need my state of matter, plus Cu plus 2 aqueous yields Cu CO3 solid. And trust me, by the time you look at 25 of these, you'll see that pattern on your own. If you have to do a few, first the complete ionic equation, that's fine. Then I have a blank line, and then I'm gonna go to reaction number 2. Maybe number 2 will be one that they're both aqueous. Okay? So here's number 2, right? Na2SO4. What am I gonna put for its state of matter? Aqueous. I don't have to look it up. Plus CuNO3. 2. What am I gonna put for its state of matter? Aqueous. What's one of my products gonna be? Who's sodium's partner gonna be? Nitrate. So it's gonna be the same formula, right? It's gonna end up being NaNO3 plus 1 minus 1. And what's its state of matter gonna be? Aqueous. Who's my other product gonna be? Copper and sulfate. Again, copper's charge is still what here? Plus 2, right? So here's my Cu plus 2 sulfate is SO4 charge of. So I really don't have to do anything, right? And if I'm making this my final copy, whoop, disappear. But you have to look at it every time, otherwise your formulas aren't right. What rule number do I look at for this one?
5?
This is a sulfate, which rule is?
so 3.
Rule 3, what does rule 3 say? Soluble. Is copper listed as an exception? No. Is it? I don't know, I'm not looking at it, but copper is not listed as one of them, so what am I gonna put for it? Aqueous. All right, let's balance this. A coefficient of 2 odd?
The sodium.
Yep. Anything else? So what am I gonna write on my second line for this one?
No.
None. Because there is no precipitant. Here's my blank line, and then I'm gonna have reaction number 3. I would like it either circle these or something so they don't look like they're coefficients. Okay? Does that make sense to everybody of what you're gonna do? This all can be done before you ever come to lab, whether that's tomorrow or Monday, especially if it's Monday, you can come to lab with this done. I would. This is time consuming. Okay? Plus, you can do it on your own and check with a friend, whoever your partner is. Okay? Hey, did you get all the same answers as me? Like, then you get an idea of if you're doing this right or not. Right? Okay? Does that make sense about what the 25 chemical reactions are? And again, that's your, what's it called under the balanced equation data sheet, right? Balanced equation data sheet is that. All right, procedure, the caution. Are we on Caitlin maybe?
Do not touch chemicals with your hands. Some chemicals,
Reagents.
reagents readily pass through the skin barrier into the bloodstream and can cause serious health problems.
Try to not touch them.
Always wear safety goggles when handling these chemicals. Some chemicals are extremely corrosive.
Yes, we will wear goggles, especially because we're dealing with pipettes. All right, part 1, the reactions.
Use the set of chemicals, acetate sheet, and reaction grid to complete the 25 chemical reactions. The number of the reaction corresponds with the number of the cell in the table that you should use it for. React 1 or 2 drops of the chemical corresponding to the column heading with 1 or 2 drops of the chemical corresponding to the row heading.
All right, let's pause right there. We're gonna make some additions and corrections to this. React, cross out or 2 drops. We're gonna react 1 drop. Okay, because these have been used a while and you probably need to wash your acetate sheet before you start the reaction and dry it off. These have been used a few times. If you start to get 2 drops and 2 drops, they're gonna run all over the place. Okay, so 1 drop. And I would put that drop, so what it's talking about here is, again, this page back here that looks like this. So I would, right there, little squares, and they're squares next to each other. I would put one of my drops, and then you put your other drop right on top of it. Don't put them here and here. I need them to react. They're not gonna react if they're there and there. I'm gonna put my 2 drops on top of each other. Okay? Does that make sense to everybody? All right, something else to notice. This says it's reaction number 1. Look at the column heading. What's the column heading for number 1? Sodium carbonate. What's the row heading for column 1 for reaction number 1? Copper nitrate. What number was this reaction?
1.
Okay. Everybody understand? So guess what? Reaction number 11 is sodium carbonate reacting with lead nitrate. look at your other page, right? With all the 25, right? Reaction number 11 on the other page is sodium carbonate and lead nitrate, correct? All of those numbers, these numbers that are in the grid correspond to these reactions. Now, what have you predicted should happen here? What did you predict should happen in this reaction? Should there be a solid produced?
Yes.
Yes. What if there isn't a solid produced? That's a discrepancy. Okay, these are your predictions. That's why I suggest you do them before you come to lab. These are your actual lab results. Right? In reaction 2, which I think is to the right, right? If I put my 2 drops on here and I get a solid, is that what I predicted? No, that's another discrepancy. Okay? So I expect when I put my 2 drops together for reaction 2 that nothing's going to happen. Does everybody see that connection? Okay. So back to our procedure. Okay, and on the side. Okay, so we changed it. We're just going to do 1 drop. And we see that the numbers here correspond to the reactions you've written and balanced. So the next, probably a couple paragraphs there, Sydney.
Hold the micropipette perpendicular to and above the acetate sheet and then carefully place 1 or 2 drops in the center of either. Do not touch the tip of the pipette to the acetate sheet. It is not necessary to stir the reaction. An alternate method of reaction and faster is to drop all of the chemicals corresponding to the column heading and then drop all of the chemicals corresponding to the row heading.
Right, so a couple things we want to talk about. First, the micropipette thing. So it's a little plastic pipette, much smaller than my marker. You're going to be working on a lab station. Your pipette is straight up and down when you make that drop, because then your drop goes right underneath it. As soon as you start to use it like you do right with a pencil, you don't control. Now your drop can come off anywhere off the end of that pipette and kind of end up somewhere you don't expect it to be. So the way to control where the drop is, and I'll call you on it if I catch you doing it when we do the lab, your pipette should be straight up and down. Okay? So your pipette should be straight up and down. And I can't touch my acetate sheet, but I probably don't want it way up here. You should be about 1 inch or so off of your acetate sheet. That way, if you wiggle a little bit, you don't accidentally wiggle and touch the acetate sheet. If you start to get like this, if you wiggle, you accidentally hit it, that's bad. You contaminate your pipette and you contaminate your chemical. Okay? And again, we're going to only place how many drops? 1. So you can cross off the or 2, right? We're going to carefully place just 1 drop in the center of the grid. We put the drop of the other chemical right on top of that drop. Okay? We don't stir them. Now, the alternate method, and I want you to make a big star next to that, and I want you to write, do it this way, do it this way. What you're going to do is you're going to take this, and you're going to have this on this acetate sheet, and you're going to get one of these chemicals. It doesn't even matter which one of the 10 you get first. And you're going to put 1 drop of that chemical everywhere it needs to go, right? Sodium carbonate is going in every single one of these cells all the way down this column. So instead of grabbing sodium carbonate 5 different times, I'm going to grab my pipette once, 1 drop, a drop in 6, a drop in 11, a drop in 16, a drop in 21, and now I'm done with my sodium carbonate. The other thing that I'm really picky about, and I'm going to use Margot's water bottle as kind of a little example here. When these are all going to be in test tubes that have tops on them, you're going to take all the test tube tops off as soon as you get in lab, and you're going to put pipettes in every single one of them. So when you're using this chemical, you're going to pick that test tube up out of the rack and have it in your hand, and have your pipette in it, and pull your pipette out, use it, put your pipette back in it, and then put it back into the test tube rack. That way, there's not two of them with pipettes out and you accidentally put it in the wrong one. Okay? And again, the nice thing about that is I think I'm just gonna do 3 groups, so it'll be 3 groups of 3. 2 people then, if they both have a chemical in their hand, they can put drops on at kind of the same time. Third person needs to keep track. All of these are pretty much colorless, clear liquids. So what I would suggest is the third person in the group, okay, who's maybe not doing drops, if Margot has sodium carbonate, to put an X on this paper through your sodium carbonate so you know that the one drop you put down there is sodium carbonate. Like X them out when you use that chemical and put the drop on there. Because they all look the same. So you can't keep track of which one did I put on and which one did I not put on. Maybe you just want one person doing the drops. That's fine too. But just keep track. It doesn't matter what order you add them in. No difference whatsoever. Okay? Does that make sense to everybody? So definitely do it that way. You have a lot of observations to do, and that allows you to kind of do them at your own pace. It'll take a lot longer for you to do the lab if you do one set, make an observation, do the next set, make an observation. Okay? And we all want to get done with the lab. Okay? So that is that. Questions about the procedure? All right, the caution. We're back to Sean.
Do not contaminate the chemicals by touching the pipettes to the puddle of chemicals or by using the pipettes as a stirring rod.
Again, that's part of why we want to stay off of there, right? Once we have a liquid here, we're going to have like a little liquid bubble. I don't want my pipette to accidentally hit that. So that's why I say try to keep your pipette about an inch off of that is good. Okay, straight up and down. All right, part 2. Data, record data, your observations, Madison.
Numbers 1 through 25, number 1 through 25, and write an observation for each of the 25 chemical reactions. Observe the reaction against the white data table and then against the contrasting background, the background. The observation should include, but is not limited to the color of the precipitate, the consistency of the precipitate, the crystalline shape of the
Precipitate.
the apparent texture of the precipitate, and do not touch the chemical reaction. The fact that no precipitate formed, none.
All right, so again, it says make 25. What most people choose to do is they write their reactions, their observations right here. If you want to like number it and do it that way, that's fine, but most people choose to do it right here. If you feel like maybe you're a big writer and it's not gonna fit there, then go ahead. But then I would come to class ready, like already numbered 1 through 25, so you're ready to go, okay? So notice what is asking you, and a couple of these we're gonna eliminate. The color, yes, we are gonna observe color. How am I gonna tell that there's a precipitate? They're both clear liquids. So what's gonna happen if I have a precipitate? They're gonna go from being clear to being cloudy, right? If I have 2 clear things that I add and now they're cloudy, then something happened. Okay? The consistency, to me, consistency and texture are the same. So you can kind of connect those and put it mark through C, the crystalline shape. We didn't talk about crystal shapes, so you don't have to do crystal shapes. To me, consistency and apparent texture are the same. So what we're talking about here is, are the particles big chunky pieces, or are they really fine? You have to be able to tell this though just by looking at it. You can't touch it. So you're just gonna look at it. Some of them look like big chunky pieces, and some of them look really fine. That's what you're kind of writing down. Okay, so maybe it's a purple solid, and it looks really fine. That's what you would write down as your observation. Okay? Continuing, Margot.
On a separate sheet of paper, use 3 lines per reaction, one of which is a spacer and that for the observation of the 25 chemical reactions.
So you guys think I'm picky, like, nope, whatever. If you want to make a data table like this and put it in your lab, that's fine. If you want to type it out as single, that's fine, I don't care. Okay, I'm not that picky. All right, next one, Rainey.
Check for the accuracy of your predictions against the actual chemical product formation. Write in the observation section any discrepancies between your predictions and the experimental result.
That's talking about this, right? We just said that. What if I mix these two and nothing happens? There's no solid. I predicted here that there would be. That's a discrepancy. Okay? If I do these two and nothing happens, that's what I predicted. I'm good to go. I don't need to explain that. But what it's asking you to do is where there's a discrepancy, like you predict a solid and you don't get one, that's a discrepancy. Or you predict there won't be aqueous and you get a solid, that's a discrepancy, okay? And then it asks you just to run a hypothesis with regards, like see if you can come up with maybe what you thought happened, okay? Really kind of which one do you think is the solid? All right, part 3, Alyssa.
Retain the completed chemical reactions on the grid, which will be used as a precondition to the determination of the unknown. Use the unknown solution that is at your lab station. Record the code for the unknown solution on your sheet of paper. Determine the identity of the unknown solution for reaction chemistry and the process of elimination. The solution is one of the 10 solutions found in this set of chemicals. Start by reacting the unknown with 3 or 4 of the chemicals from the set. The chemicals that you choose to react your unknown with can be eliminated as the unknown based on their physical characteristics.
Okay, so number 1, there'll be 2 unknowns. And actually, if you have time, I'd like you to do both of them, okay? Because you're gonna be a group of 3 working with your chemicals, okay? The code, that's a letter. So what I need to know if you've done it correctly is your code. Now, you are not done with the lab when we do it until you've checked with me and said, hey, I have letter Z, and my group has decided that Z is sodium chloride. And I'm gonna say, yes, you're right, you're done, or nope, keep thinking. Okay, you gotta go back and rethink. Okay? So, you need to write down though, and that's the part that's missing on here. So when you make a note, you need to write down what you do each time. So if you have unknown Z and you decide that you're gonna add potassium hydroxide to it, you're gonna write Z plus KOH, and now you're gonna write some observations. Hey, we got a purple fine solid. Okay, or maybe nothing, right? None. They just stayed liquids. Nothing happened. You need to write this down each time you do it. And from here, you're going to compare potassium hydroxide column and see, does this look like one of your reactions? If it is, well, maybe Z is whatever it is. Maybe it was a lead, and potassium hydroxide produced a purple fine solid. Hey, I think Z then is the lead nitrate. Now I'm going to add Z to something else that lead nitrate reacted with and hope I get the same observation. Your goal is to identify your unknown in as few steps as possible, 2 or 3. But you have to talk as a group about what to react it with the first time, and after you have your results, you need to talk as a group. Like, what are we going to try next? Does that make sense? Now, the other thing I want you to make a note about is, if Z is potassium hydroxide, and I add KOH to it, what's going to happen? Is anything going to happen? No. You got to keep that in mind. Right? If I have KOH and I add KOH to it, nothing's going to happen. So don't let that, sometimes when nothing happens, people get really upset about that. I want to say potassium hydroxide is one of the ones that like reacts with everything. And then I add it and nothing happens. Oh, that tells you a lot. That tells you that that's probably potassium hydroxide. check it with something else. Okay? Continuing, are we on Sydney? The record.
Record observation section, the method and steps that were used to determine the identity of the unknown. Record observation section, the identity, name, and formula of the unknown.
Right, so this is what that should look like. And if at the end I've decided that Z is KOH and Mrs. K has told me I'm right, then at the end of this it should say Z equals KOH. Or whatever your group has decided and I confirm that you're correct. And that's what you're gonna nicely handwrite out or type up, okay? It might be handwritten again, okay? For that unknown data sheet, okay? The cleanup, you won't dispose of them by pouring them down the drain because you're just gonna put the tops back on them and I use them for Chem B next trimester, okay? The pipettes, make a note, the pipettes are gonna squirt any liquid that's left in them back into their test tube and the pipettes just go in the trash. They're disposable pipettes, okay? I would like you to wipe your bench and such. You'll return the chemicals to me, I'll go put them away, okay? Put your goggles away. The questions there, the only thing I want you to draw attention to for the questions is look at number 3, which cation was responsible for the blue solution. So a suggestion that I have for you is with these, if one of these solutions you're using has a color to it, write that down. Like a potassium hydroxide, it's not, but if it happens to be purple, you would write potassium hydroxide is purple up here so that you know that. So that you're ready to answer that question there about the colors. So any of these solutions that you start with that are colored, write that down. What that also means is, if I said that potassium hydroxide was purple and my Z is not purple, is Z potassium hydroxide then? No. So you can use the color to kind of figure out, hey, there's only one blue solution and my unknown's blue. It must be that one. That's fine. Okay? Questions about the lab? We went through all of the stuff, right? Okay? Remember, I'm not going to see these papers ever again. Right? This page, you're going to handwrite out in pen, nicely and neatly, okay, on a lined sheet of paper. Okay, so I'm never going to see that again. Oops, sorry.
That's okay, I just don't want to forget it.
Okay? Questions about this? I know you don't have a ton of time, but I would suggest you start writing these reactions. If we have school tomorrow, the most ideal situation would be for you to come to the lab tomorrow with these 25 reactions already balanced. You don't necessarily have to have your net ionics, but it's the idea that I know that I'm expecting a solid here and I don't get one over here. Because now as a group, you guys can kind of talk about that a little bit. Okay? So I would suggest you kind of get started writing these 25 reactions. The other thing is, on the pop quiz you have next week, you have to do these net ionic equations. Not all of them, not all 25 will have, some of them are going to be none, but probably half of them or so at least. Okay, I'm eyeballing, I don't remember exactly, but you're going to get practice 8, 10, 12 times writing a net ionic equation. That will help you Monday when you have to take that quiz and you have to write a net ionic equation. If you do this all after you take your quiz Monday, you're probably not going to do that great on that quiz on Monday. If you do this all before you take your quiz Monday, it'll probably mean that that quiz is going to be a lot easier. And you'll be comfortable using those solubility rules and such. Okay? Does that make sense to everyone? Right. So that gives you a couple more minutes here to finish up. Oops, I did what I didn't want to do, which was get my